So this is our last bit about proof by induction, so we have to look at divisibility proof. So that sounds like kind of a complicated word, but I'll give a brief kind of introduction for it. So you need to know that, say if we have a number here, x, and you can write x as 3 multiplied by k, where k is another number. So I'm just going to write x and k are numbers, and obviously 3 is a number as well. So this means that, write it here, that 3 and k are factors of x because you multiply them by each other to get x. So they're factors of x, you need to know that. And also, another way of saying that is that x is divisible by 3. Divisible or divisible, I don't know how you say it really. Divisible by 3. So those are two ways of saying the same thing, that 3 is a factor of x, or x is divisible by 3. Basically, you can divide 3 by x. You can divide, x by 3. And that's what we have to prove. We have to prove that numbers are divisible by 3 or 2 or anything like that. So we have to prove that basically 3 is a factor of whatever term or number we have. So that's the trick. If you can write whatever they give you in terms of 3 multiplied by something else, then you've proved it. You've proved that x can be divided by 3, which means that x is, divisible by 3, and that's your proof done. So hopefully that makes sense. If it doesn't, we'll do an example, and it should make a little bit more sense. So I'll scroll down now to show the example. So here's our example here. We have to prove by induction that 4 to the power of n minus 1 is divisible by 3 for all the natural numbers of n. Alright, so that means we have to prove that 3 is a factor of this. So like I was kind of saying up there. So hopefully it'll become clear. So the methodology is still the exact same. We're still going to follow the exact same steps. So step 1, as always, we have to prove this for n is equal to 1. So we have to prove it's true for n is equal to 1. So we're going to have 4 to the power of 1 minus 1, and that's equal to 3. And we'll say this is divisible by 3, obviously, because it is 3. This is divisible by 3. So therefore it's true. So it's true for n is equal to 1. We have that proved. Now the next step is that we're going to assume that it's true for n is equal to k. So the same as we've always been doing. So now I'm going to write assume true. Well, I'm going to make that a little bit more spaced apart, sorry. Assume true for n is equal to k. So like we've been doing for all the other questions. So that means we're going to have 4 to the power of k minus 1, and that's divisible by 3. So I'll say 4 to the power of k minus 1, I'm going to put a bracket around it, is divisible by 3. Divisible by 3. I really hope I'm not saying divisible wrong. Now, the step 3 is we have to prove that it's true for n is equal to k plus 1. Prove true for n is equal to k plus 1. So now we're going to have 4 to the power of k plus 1 minus 1. So what we're going to do here is we're going to break this up using indices. So that means that's going to be 4 to the power of k times 4 to the power of 1 minus 1. And the next step I'm going to do is going to be a little bit weird. 4 to the power of k multiplied by 3 plus 1 minus 1. So again, 4 is just 3 plus 1, so we're writing that in a different way. And then I'm going to multiply this out. So normally you just add them together and go back to where you started. But now I'm going to multiply this out. So we're going to get 3 multiplied by 4 to the power of k plus 1 multiplied by 4 to the power of k. So I'm just going to write 4 to the power of k. And then minus 1 is the last thing, right? So now what you guys might spot is that 3 multiplied by 4 to the power of k is divisible by k, or is it divisible by 3 because 3 is a factor of it, and 4k to the minus 1 is also divisible by 3 because we assumed that. So that means that I'll say both terms are divisible by 3. Both terms are divisible by 3. Divisible by 3, and therefore true for n is equal to k plus 1. Okay, so that's it done there for n is equal to k plus 1, just in time. So that's step 3 proven, and again the last step is going to be our finishing statement, finishing sentence as always. Step 4, you say it is true for all n is equal to k plus 1, assuming it is true for all n is equal to k. So since it is true for n is equal to 1, it is therefore true for all n in a set of natural numbers. So that's all you have to do to prove those divisibility proofs. So the trick to divisibility proofs is, one, you have to make sure you write them in this form. So we write them so that you can see that 3 is a factor of them, or sometimes it might be that you want that 2 is a factor of them, so you have to write it like this. And then as well, there's this little trick is really handy, so breaking something like 4 up into 3 plus 1. So we're going to do that in the next video as well, where we're going to look at another example of divisibility proofs. So you have to break up, say, 4 into 2 numbers, and we'll see that again in the next example, like I said. So I hope you guys enjoyed it. Don't forget to like and subscribe and share it if you find it useful, and we'll see you in the next video where we're going to do another divisibility proof.